Hello guys and welcome back to Leet Logics. This is the poor picks and it is a LeetCode art, but it won't be a hard question if you watch the video till this end. The number is 458. So in this question, we are given with integer buckets, minutes to die and minutes to test. And our task is to determine the minimum number of picks needed to identify the poisonous buckets within the specified time. So there is certain conditions in this question that we can feed the pigs according to these steps, like choose some pigs to live pigs to feed. Then for each pig we can choose the buckets to feed, and then we have to wait for minutes to die uh, before feeding other pigs. And after this we after minutes to die have passed and any pigs have been fed with poisonous bucket, we check if how many buckets are poisonous. uh, in this actually only one bucket is poisonous and we have to find that. To the intuition for this problem is like we can solve the problem, but we will need to find a way to maximize the number of buckets each pig can be tested within the given time. Like for the number of pigs, we want to maximize the buckets covered, and the idea is to perform test in parallel using multiple pigs, and the more pigs we use, the more buckets we can test simultaneously. The approach involves the use of a formula, that is mat.power, and there is a factor which is minutes to test upon minutes to die plus 1 raised to the power number of pigs. So this will give us actually the buckets covered. So you can see there is the number of pigs is 1, and the factor will be minutes to die upon minutes to test plus 1. So minutes to test upon minutes to die will be actually 1 and plus 1, so that becomes 2, and 1 is the number of pigs used, and in the next iteration the number of pigs used is 2, so it will become 4. So in this way we can certainly find the number of buckets covered, and then as soon as the number of buckets covered is equal to the given buckets, we can return the answer in the form of the pigs. So let me give you a dry run of the example. First of all, we have the sample example 1. The buckets equal to 4, minutes to die equal to 15, minutes to test equal to 15. So for the first iteration, we take the number of pigs as 1, and we try to calculate how many buckets can be covered. So mat.power minutes to test upon minutes to die plus 1 comma 1. This one is the number of pigs used, and this comes from the minutes to test upon minutes to die plus 1. So the number of buckets covered is actually 2 here, which is less than the 4 which is given in the question. So we have to go in the next iteration. We have the number of pigs equal to 2. We put into the formula, we get equal to 4, the number of buckets, which is equal to the number of buckets given in the question. So we'll return simply 2. So this is the simple logic which I have derived. So let's come to the code section. But before that, please do like the video, please share it with your friends, and please subscribe to the channel. Almost 90% of the people don't subscribe to my channel who watch the video. So first of all, we'll check if buckets equal to 0. Then it means that there are no buckets to be checked. Then in that case we'll return 0. Otherwise, if minutes to test is less than minutes to die, then we'll return 0. Otherwise, if bucket equal to 1, and we know that for every question we have at least one poisonous bucket, so this will be a poisonous bucket, so we do not need to check any of the pigs, so we'll return 0 again. Otherwise, we'll set the initial number of pigs as 1 to be tested, Then we'll put the formula while at dot power minutes to test on minutes die plus 1, and we have to give here numpicks, number of picks is less than buckets. If it is equal to or greater than, then we can break and return the number of picks. Otherwise, number of picks plus plus. Some spelling mistakes. The sample test cases are passed. Now let's check for all the test cases. So it is passed with a good runtime. So the space complexity for this question is O of log of buckets. The while loop iterates until the num pick satisfies the condition, which is the logarithmic of the number of buckets, and the space complexity is definitely constant because we are not using any data structure in this case, and neither recursion stack. So this solution provides an efficient way to minimize the number of picks. This is one of the simplest approach which you can use to solve this problem. Nobody will tell you a more simpler approach than this. I hope you liked the video. Please do subscribe to the channel. Thank you for watching the video. Have a nice day.